Yevkar. Molecular orbital theory is one of the most powerful concepts in chemistry that explains the chemical bonding. It not only explains how atoms bond but also predicts important chemical properties like magnetism, color, and stability. Molecular orbital theory was developed in the years after valence bond theory had been established in early 1900 primarily through the efforts of Robert Mulliken, Friedrich Hunt, John C. Slater, and John Lennart Jones. Today, let's focus on an interesting question. Why are the pi and sigma orbital energy levels different in nitrogen, N2, and oxygen, O2? If you've looked at the molecular orbital diagrams of N2 and O2, you might have noticed a difference. In nitrogen, the pi bonding orbitals formed by lateral overlap of p orbitals are lower in energy than the sigma bonding orbital formed by axial overlap, but in oxygen, this order flips. The sigma orbital drops below the pi orbitals. So, what must be happening here? To understand this, let's first ignore the inner one's orbitals, since they don't participate in bonding for elements beyond lithium. That makes our diagrams much cleaner. Now, as we go across the periodic table from lithium to beryllium, boron, carbon, nitrogen, and then oxygen, the energy of atomic orbitals decreases. This happens because electronegativity increases, pulling electrons closer to the nucleus. Beryllium molecule Be2 is never formed as bond order is 0. But here we must remember that the sigma orbitals, formed by strong axial overlap, are much more sensitive to this energy lowering. The pi orbitals, formed by weaker sideways overlap, don't shift as much. At lighter elements like boron, carbon, and nitrogen, the pi orbitals stay lower than the sigma orbitals. But as we move to oxygen and beyond, the stronger axial overlap pulls the sigma orbital below the pi orbitals. This is known as the orbital crossover, and it's the reason why the MO diagrams for N2 and O2 look different. So, in short, in N2, the pi orbitals are lower than the sigma orbital. In O2, the sigma orbital is lower than the pi orbitals due to stronger overlap and higher electronegativity effects. Molecular orbital theory not only helps us understand bonding but also reveals why small changes in orbital energies lead to such big differences in chemical behavior. Hope you find this explanation useful. Happy learning.